Welcome everyone. This is Math 1332, the video lectures. Chapter 1, Section 1. Chapter 1, Section 1 deals with problem solving. The process of problem solving, there is no one right answer, because it all depends on what you're given, what you have to work with, and what the problem is. So we're going to look at three particular parts. One is called inductive reasoning. Second one is called deductive reasoning. And the third we're going to talk about is called counter example. Counter example is a way to prove whether something's right or wrong. Let's begin. Inductive reasoning is when we observe an event and then make a general conclusion. From or about that observation. Remember, we're observing a specific event. That's the first one. That's inductive reasoning. Deductive reasoning is when you make a specific conclusion from one or more general observations. Or statements. Inductive reasoning is what we use in the sciences: engineering, mathematics, physics, chemistry, biology. It's when we observe a specific event, we go from specific and we make a general conclusion. Go from specific to general. And then deductive reasoning is just the opposite. We begin with a general observation or a general statement of something, and from there we make a specific conclusion. That is pretty much done like lawyers in law school. You're given the general, you're given all these events that you observe, statements that people made, and then from there you conclude with a specific conclusion. A counter example. A counter example if you can find one, just one example where the conjecture or hypothesis is false, then the entire conjecture or hypothesis is incorrect. So all it takes is one proof. All you find is one element, one example, one time where it doesn't work. And then the whole thing's wrong. So I use the words conjecture and hypothesis. That's what we use in inductive reasoning. Is we come up, we observe something, and then we make a hypothesis. We make a educated guess of what's going to happen. As opposed now, if a deductive statement is true, then it's called a theorem. All right, so that's the difference. So a hypothesis is used for inductive reasoning, and theorems proven because it's going from general to specific. Hypothesis is still a guess. Until we prove it right or wrong, we can't do anything about it. All right, so let's look at some examples here. First one. These are from your homeworks. All right. Here's the first one. Find a counterexample to show that the statement is false. Remember, a counterexample is just one event where it's not correct. If a number is multiplied by itself, then the result is greater than 0. Is greater than 0. Now, is that a true statement? Well, let's see. A number has to be multiplied by itself. 3 times 3. 9. That's greater than 0. Negative 3 times negative 3. Negative times negative is positive. That's greater than 0. But what if we have, it didn't say specify, it's a number. How about 0? 0 times 0 is 0. Is 0 greater than 0? No. So there's our counterexample. So the answer is B. Number 2. Identify a pattern in the list of numbers, then use that pattern to find the next number. So we have 3, 10, 17, 24, 31. What's the next one? Well, first we would check. Notice that these numbers increase. From 3 to 10 is 7. So we find the difference. 10 minus 3 equals 7. That's the difference. How about 17 minus 10? That equals 7. How about 24 minus 17? That's also 7. So we're seeing a pattern here. 31 minus 24 is also 7. So to go from one to the next, we have to add 7. From one to the next, we have to add 7. So from 31, if we add 7, we get 38. The answer is B. Let's look at number 3. Again, identify the pattern in the list of numbers. Then use that pattern to find the next number. We have 27 23, 19, 15, 11. Again, same thing. Let's look for a pattern. Is there a common difference? The difference is always taking the first number and the second number. Take the second number minus the first, and that's the difference. So 23 minus 27. Since they have different signs, 27 is bigger than 23, the answer is negative. 27 minus 23 is 4. Let's do the next one. 19 minus 23. 23 is bigger than 19, it's negative. 23 minus 19 is 4. 15 minus 19, again 19 is bigger than 15, it's negative. Difference is 4. 11 minus 15 is negative 4. So what we have to do here is from one to the next, we have to subtract 4. 27 minus 4 is 23. 23 minus 4 is 19. 15 minus 11 is 4. Minus 4 is, 11 minus 4 gives us 7. So we see a pattern here. Fractions. Identify the pattern, list of numbers, then use the pattern to find the next number. But this is pretty tricky because what we notice, this is 4, not 2. We notice that first off, the sign changes. So it goes from negative to positive, positive to negative, negative to positive. So we know the next number is going to be a negative. Negative, positive, negative, positive, negative. So we know automatically C and D cannot be right. Let's see a pattern here. All the top numbers are 1. That's okay then. So what we have here is it's growing. So we start with the first one. This is the list one. We have the first number, second number, third number, fourth number. We're trying to find the fifth number. How are 4 and 16 related? 4 times 1 is 4. 4 times 4 is 16. 4 times 4 times 4. So what we're noticing here, we have a pattern. It starts off with 1 over 4, and these indices are 1s. So when negative 1 over 4 to the first power, it only happens once, so it's negative 1 over 4. Check. Next one we have negative 1/4, n is 2. So negative 1 over 4 times negative 1 over 4, negative is a positive. 1 times 1 is 1, 4 is 16, positive. That works. So the next one, negative 1 over 4 to the third power, which is negative 1 over 4, negative 1 over 4, negative 1 over 4. Remember, an exponent simply means how many times what the base, number below it, is multiplied to itself. Negative times negative is a positive, times negative is a negative. 1 times 1 times 1 is 1. 4 times 4 is 16, times 4 is 64. Check. So it works out. And I bet the same thing is going to happen 1 over 4th to the fourth number. So what we're looking for is to the 5th. What do we know so far is every time we're multiplying by another 1 over 4. So we can start with this one, which is negative or positive 1 over 256, and multiply by negative 1 over 4. So that's the pattern. Every time we're multiplying by another 1 over 4, negative 1 over 4. We start off with 2 of them, 1 more. Same thing. We start off with 3 of them, and 1 more gives us that. So the answer is going to be negative. Positive times negative is negative. 1 over 1 is 1. 256 times 4. 6 times 4 is 24. 5 times 4 is 20, plus 2 is 22. 4 times 2 is 8, plus 2 is 10. So it's negative 1 over 1024. It's B. Alright, let's look at the next set. Ooh, now use deductive reasoning to predict the next line of patterns. Then perform the arithmetic to determine whether the conjuncture is correct. So 3 times 3 is 9. 33 times 33 is 1089. 123 times 123 is, we still have 110889. So what's the pattern here? We have 108 in front of the 9. Here's 108. We have a number 1 and 8 after it. So the more 3s we have, if we have 4 3s, then we're going to have 1, 2, 3, 0, 1, 2, 3, 9. Because we're looking at it's growing. The 0 stays in the middle. We're adding 1 more 1 and 1 more 8. 1 more 1 and 1 more 8. So, since we have 4 3s, we have 3 1s. 4 3s, 3 1s. So the answer is B. Use inductive reasoning to predict the next line of the pattern. Then perform the arithmetic to determine whether the conjecture is correct. Alright, 37037 times 3, straight 1s. 37037 times 6, straight 2s. So this is increasing by 1. These numbers stay the same. Only thing changes as these increase by 3. So 37037 times, add 3 to this one, is 15. Should be 5, 5, 5, 5, 5, 5. So we're predicting that. But you can use the calculator and check if you want to. Which reasoning process is shown in the following example? We examine the Social Security number of 500 people. No 2 individuals from the group of people have identical Social Security numbers. We conclude that all people, no 2 people have identical Social Security numbers. So what does that mean? Now, is that remember, inductive goes from specific to general. Deductive goes from general to specific. So because of that, remember we started off with inductive goes specific to general. Deductive goes from general to specific. It's not theoretical reasoning because we haven't talked about that. Reasoning by counterexample, there's no counterexample there. It's just a statement. So it's either inductive or deductive. And we begin by specific. We begin by specific informations. Because remember, we're observing these Social Security numbers. So since we're going from specific to general, we got it's inductive. Now an algebra question. Study the pattern of the trend. Then select the expression that best describes the amount of tickets sold in thousands n years after 203. So we notice all these answers. First off, we notice it's going down. So from algebra, remember, if we drew a line here, it's going down. So think of the y equals mx plus b. Since the slope of this curve is down, whatever number we have here has to be negative. And the slope is whatever's in front of our variable. Our variable in this case is n. So we cannot use these two because the number in front of n is positive. Alright, so let's see, since the first number is the same, that's where it starts off, let's see how far it's going down. Take the second number. Remember, the way you figure out it's a difference. Take the second number, subtract the first. So we have 2298 minus 2506. Since 25606 is bigger than that, we know it's negative. And we subtract 2506 minus 2298. We can't, 6 minus 8 you can't do. So we have a 4 there. Becomes a 9. So we have a 16. 16 minus 8 is 8. 9 minus 9 is 0. 4 minus 2 is 2. So it's negative 208. And it's going from 2003 to 2004. So that's 1 year. So the pattern of the number of tickets sold in 1,000 years is let me see what the question is, because it's asking how many so we have from there. Then select the expression that best describes the number of tickets sold in thousands n years after 2003. So we see a continuous pattern. It loses 208 each year. Is it 208 each year? And 2003 minus 2004 is 1. These are years. These are tickets sold in thousands. In n years. Alright, so looking at this, we have 6, 5, 6. So let's see here.